In this video, I'm going to talk about how to set up a normal distribution calculator in Excel. So I've already set up some of this. I put my name and date at the top of it. I'm going to go ahead and merge and center these. And so I have a merge and center option right here at the top. And so I merge and center. I might write a paragraph here. Again, I've already merged and centered this, but I might type it out here initially. When I first type it out, it's all this in one big ugly cell. So I'm going to push Shift and down and highlight and over, highlight a bunch of cells so that I can merge and center all of those cells. So I've merged and centered those. It doesn't quite get all of my paragraph in, so I'm going to add a few more. I'm going to click the merge and center 2 more times. So one time we'll undo the merge and center I did previously, and then the second time we'll add in those new cells. So I've merged and centered this. All right, so let's look at setting up single element probabilities. And so I have a mean space and a standard deviation space. I've chosen this values of 63.6 and 2.5. You can change those, and you should be able to change these later on. But for now, these are the numbers I will use. I've highlighted those yellow. I used my fill up here. I placed borders around these cells just to make it look nice. There's a couple different ways, but one of those ways is up here. I could choose, I want all of those borders around those cells. So again, I highlighted those cells, pressing Shift and holding down on Shift and then down to highlight the cells I wanted to have the borders around. All right, so the first thing I want to do is identify the chances of being less than a value. So I input a spot for A, I highlight that cell with yellow. These are values that I can change inputs later. They would not be calculated. Those are values that I am inputting. And then I'm going to have it calculate the z-score. And so to calculate the z-score, I need to take this value right here, that value of 70, subtract the mean from up here, and then divide by the standard deviation right here. And so I do that with a formula. I don't want to use those specific numbers because I want this to update when I change those numbers. Right? So I'm using the cell addresses. Right? So I put equals to say this is a formula. Then I put a left parenthesis, and then I chose C2. Right? So that's where the 70 is, minus the mean, which is in C10. Close that parenthesis and divide it by C11. Right? And so that calculates the z-score. To calculate the probability it's less than or equal to some value, I go equals normal dist. The cell address for the data value, so for that 70, so I have C15. So the cell address for that value, then the mean, and then the standard deviation, and then comma 1. We'll just use comma 1 each time here. It's actually saying that we're looking for a cumulative distribution instead of just the density of this function. All right, so once I have that in there, I'll press enter. And if I change this value from 70 to, say, 35, this should update. So the z-scores have been updated, the probability has been updated. If I change it to 60, it should update to something new, right? And so we are able to go through that without too much issue. Right? So those are chances of being less than a value. That's kind of like part 1. Part 2, chances of being more than a value. It's pretty similar. We have that value of B now. We want to know what's the probability we're more than the value of B. We calculate the z-score using this value of B here and the value of the mean and standard deviation from above. Right? So we do that just like we did before. And the only thing that's going to change in this calculation. Oh, and this should say probability of x being greater than or equal to b. So the thing that's going to change here is that normal distribution is going to have the 58, the cell right here listed first, so that 58, so C20 is listed first, referring to 58.1. The value of the mean, or the address of the mean, the cell address of the standard deviation, and then comma 1 again. But we are going to take 1 minus that normal distribution because this normal distribution function is giving us an area from the left. And so if we want to know what's the chances of being more than a value, we want the area to the right. And so we take 1 minus that value. And so that's that portion. Being between two values, we do, again, pretty similarly. We calculate a z-score for our value of A. We calculate a z-score for our value of B. And then we use two different normal distributions. So we find the area to the left of A, the area to the left of our B value, of the larger value, and subtract from it the area to the left of our A value. If we want to go the other direction, knowing an area, and we want to calculate what is the probability, or what is the, knowing the area, what is the z value or the data value that's associated with it, we can input the area to the left. And so here I formatted this as a percentage. So the way I formatted it as a percent, initially it was just a number, but I chose up here, change that to a percent. You can change the formatting of that up here, but I formatted it as a percent, so it will show up as a percent. If I wanted this to show more decimal values, I can show more decimal values or fewer decimal values. So I'm going to show 2 values after the decimal with this percent. And then to calculate the data value that's associated with this area to the left, I choose the normal inverse, so equals norm inv, and then a left parenthesis, the cell address for this percent, so C32. Then C10 is the cell address for the mean, and C11 is the cell address for the standard deviation. So I calculate both of those, or plug those in. And so now if I change this percent, I want to know what value has 5% to the left. I can change that, and it updates there. That has 5% to the left, provided that the mean is 63.6 and standard deviation is 2.5. So that from above. Right. And so if I change the mean or standard deviation above in those yellow boxes, it would update here as well. And then the last thing, the values associated with the top B percent. We have this. It's very similar, only we are going to go norm inv of 1 minus this value here, but it's the cell address for that value there. So 1 minus the C36, or wherever you might put that, the cell address of that percentage. All right, in the next video, we will take a look at how to go through this process for sample probabilities. All right, we'll talk to you in the next video.